AMC 2004, problem 20. Points E and F are located on square ABCD so that triangle BEF is equilateral, and we're trying to find the area of DEF to ABE. So we're told that BEF is equilateral, so therefore we are given angles. Now, if we're given angles, we want to relate it to trigonometry. That is always the best thing to do. So we're told that this is equilateral, so each angle of this triangle will be 60 degrees. Now, if each of these are 60 degrees, what can we say about the other triangles? We know that triangle EAB and FCB are right angles because we know that they are part of a square. And they both share the same hypotenuse because it's an equilateral, and they also share the same base, which is CB and AB. Therefore, the two right triangles are congruent to each other, meaning that this angle, if we call it theta, will be congruent to this angle right here. Since they form a right angle, 2 theta plus 60 must give 90 degrees, so 2 theta must give 30, so theta must give 15 degrees. So if theta is 15 degrees, this is 75 degrees, this must be 45 degrees. So this is 45, this is 75, this is 15, and likewise for this theta. Now, given these theorems, what can we say about area DEF to area ABE? So to do that, I'm going to scroll down and we can begin the ruling process. So the larger triangle, which is the 45, 45, 90 triangle, DEF. So DEF, the area will be the same thing as x squared if we call the side length of the equilateral triangle to be x times sine 45 degrees times cosine 45 degrees. The reason for this, x times sine 45 degrees will give the height. X times cosine 45 degrees will give the base. And then we can multiply by this together with 1/2 to result in the area. So given this, we can move on to the next one, which is the same process. Area AEB is the same thing as x squared times sine 15 degrees times cosine 15 degrees times 1/2. Why is it 1/2? Because it's base times height divided by 2. The base is x times cosine 15. The height is x times sine. Multiplied by half will give us the area. Instead of trying to find the ratio of this, we can simply draw a long dash over it to form a ratio. Now, the like terms of half and half get canceled out. Same thing with x squared and x squared. So all we're left with is sine 45 degrees over times cosine 45 degrees over sine 15 and cosine 15. Now, what does this remind you of? This is awfully similar to the double angle. Sine 2 theta is the same thing as 2 sine theta cosine theta. So we're only left with sine cosine theta. So what can we do in order to relate it with the double angle? Well, that would be sine theta cosine theta is the same thing. If we divide 2 on both sides, half of sine 2 theta. So sine 45 times cosine 45 will be the same thing as half times sine 2 times 45 to be 90 degrees, and to be sine 15, 15, which will be the same thing as half of sine 30. So that will be our final relationship. Now, what is sine 90 degrees? Sine 90 degrees is equal to 1. Sine 30 degrees is equal to 1/2. Half and half gets canceled out, so only left with 1 over 1 over 2. Simplifying this gives 2, meaning that our final solution will be answer choice D.